Okay, I've been meaning to do some transformations in the complex plane for some time. Questions and these little videos take longer than I expect sometimes, so apologies for the delay. And I've chosen this one first because it's a little bit unusual, and because this is an alternative to those who are self-studying, looking at through the Fp2 textbook. The solution bank, I really think, has made hard work of this. A lovely resource, the Heinemann textbook. So if anyone from Heinemann is wanting to take me off YouTube, please don't. This is just an alternative to the solution bank, and I think you'll agree, far more efficient. It's not that common to have this type of transformation, but where it does come, and we have a circle, I would use the form Z is equal to R cos theta plus I sine theta, sometimes called the polar form. In these cases, I wouldn't necessarily do this unless you were directed for it in the question, or you have this type of transformation. Otherwise, other techniques like the modulus technique or rearranging and comparing values of U and V to the X and Y and that type of thing. But here, I think subbing in and doing like they did in the textbook, where they basically subbed in X plus Y in here and then dealt with the circle, is making hard work of it, I believe. I hope you'll agree when you see this. Right, now, in this case, the radius is 2. So we can just sub in Z, let's just change that to 2 cos theta plus I sine theta. But obviously if it was circle radius 1 or radius 4, then you would change your value of R accordingly. And as I say, modulus techniques normally are preferable for this type of question. So please don't regard this as a technique that should be used widely. It's really very specific for this case. Okay. This type of case. Hopefully, if Edexcel had a mind to ask a question like this, they might give a little bit of a hint in the part A of a beta question, where they say so that this is the case or otherwise, or something of the like. Anyway, let's sub in W. Let's sub in our values of Z now. So we're going to sub that in. So we have 2 cos theta plus I sine theta plus 4 over 2 cos theta plus I sine theta. Okay, now the lovely De Moivre's theorem is going to help us here. That's W is equal to 2 cos theta plus I sine theta, and the 2 cancels with the 4 to give us 2 cos theta plus I sine theta to the minus 1. And using, as I say, the De Moivre's theorem, that's going to be equal to 2 cos minus theta. We know, hopefully we know where this is heading, because the cos function is an odd function and the sine function is an even function. So that line I've just written is kind of optional, really. Because, as I say, when we see that, it's a common thing, in fact, that 1 over cos theta plus I sine theta is a common application of De Moivre's is this. So it's quite okay to use that straight away, but I've just tried to show how this is just follows on from De Moivre's. Okay, so please don't be multiplying by the complex conjugate here. It'll get you the answer, but it's making life hard, like FP1's type thing. De Moivre's is our friend. And what we find is we've got sine theta cancelling now. So that gives us W is equal to 4 cos theta. Okay, the I bits cancel. Well, we've done it. It says with the W, so therefore as theta varies, so there's no imaginary part here. As theta varies, so we've got points along the circle, all the points along the original circle. So as theta varies, W varies from -4 to 4. So I take the values on real axis -4 to 4 because of the 4 cos theta. There's no imaginary part here, it's cancelled. We're on the real line, but we also can't go beyond -4 and 4, which actually answers the question nicely. And I believe, please agree with me, slightly nicer than the rather long way that's offered in Solution Bank. Hope you found that helpful. Please regard this as a marginal thing, but the question is, after all, in the textbook, and I feel kind of compelled to offer an alternative which is more efficient than the one offered in Solution Bank. Thanks very much. Bye.